Hi, today I'm going to show you how to use Kubetorch to launch a GRPO training. Before I dive into the code example, I just first want to show you how the program is going to flow. From our local environment, what we're going to do is launch a trainer service on GPUs in Kubernetes. From within that service, we're going to then launch separate services to do the code execution. Because we're using the TRL library, we don't need to split out the inference as a separate service, but in a different RL training loop, you may want to actually launch a third service, such as the training, the code execution, and also the code generation as part of an inference service happens on 3 different sets of pods with different image requirements and different resource requirements. These pieces can then interactively call each other seamlessly in order to do the steps of the RL training loop. Now let's jump back to the code. I'll start at the very bottom where we actually go and call everything. Within main, we hard code some configs and then just call my main function. In my main function, I'm going to go ahead and define an image to run the training on. And I'm going to say I'm going to need 1 GPU here. I have a A100, and that's going to be able to successfully do the training and the inference for the 1.5 billion parameter Quen model that I have. I'm going to send that to my compute that I defined here with a base image and a couple of installs for convenience. You can see TRL and SweRex here. And I'm going to call load dataset on this trainer, and I'm going to go ahead and train a couple epics. The trainer itself is a little bit long, but there's a couple key components that I'll call out. The first is that within the trainer, we obviously instantiate the GRPO trainer, and the 3 major components are the model that we're going to train. That's the Quen model that we named earlier. The reward function, which I define here, and you can see that within the reward function, I use something called self.agent to execute code and then calculate the reward with that code execution. That agent is defined by this method launch sandbox. I have here a launch sandbox method. This launch sandbox method will create on 0.5 CPUs a code agent to actually go and run some Python that I pass to it. I defined this code further up, and I can show you in a minute, but each replica should run on 0.5 CPUs. It should have access to NumPy and Pandas because those libraries might be used in the code testing. And when I call this code agent, which is now being stored in this self.agent, what I can get as a result is a automatically auto-scaling service. And if you call against it from a single thread, obviously the trainer will just make calls to 1 replica. But if you have a distributed training and you call against that code agent across multiple threads, we will automatically round robin and load balance for that service. And so you can actually do multiple inferences and multiple evaluations in parallel, all with this extremely simple API. Just to briefly show you what's actually in the class, we just kind of init a local runtime, which comes from the SweRex library. And then we have an execute code method that goes and runs the code and captures the standard out and standard error, as well as logging whether it was successful or not, and we return that. The result of this code execution then gets passed into the calculate reward method, and then that goes and feeds into the GRPO trainer by way of the GRPO reward function. And so the main thing to note here is that, first of all, the code is actually extremely simple. My trainer encapsulates my training and gets started on a GPU, but then from within that trainer, I'm able to start the second service, which is my code agent service, and then I can ping code generations out to that service and have that return the results to me, which then calculates the reward. So execution of this is pretty easy. If I call Python TRL, you can see that we're going to start the sandbox training. This service is already warm, so I already ran it before. And what that means is that we'll keep those pods warm for you. And then any changes that you make to the code will be hot synced, and it will be about 2 seconds to restart the training. You can see that I'm already there. We loaded the data set with those 5 hard-coded prompts, and that we're going to train this. It's not 100 steps. It's going to be much fewer than that. You can see that the remote code execution has the log stream back to local. And if I go ahead and open a new window, if you can see that I can, if I use Kubetorch to list my services, you can see that I have a code agent service, which is a Knative service with auto-scaling conditions, and then I have this sandbox trainer. The training keeps going. You can see the log stream back. We can see the advantages get printed. This one was a failure, and some of these were okay. I think maybe they didn't have code evaluation, but we'll go ahead and train this for a couple epochs, and it will keep going and keep streaming the logs back. And the training just flows, and RL is going to do magic for you.